blood test indicates the presence of a particular disease 96% of the time when the disease is actually present. The same test indicates the presence of the disease 0.5% of the time when the disease is not present. 3% of the population actually have the disease. Calculate the probability that a person has the disease given the test indicates the presence of the disease. So first of all, we just need to come up with some variables here, and we need to know what we're looking for. So we're looking for the probability that a person has the disease. So I'm going to say that's going to be D, means they have the disease, given that the test indicates the presence of the disease. So I'm going to use P to stand for the test indicating the presence of a disease. So this is what we're looking for. Okay, so let's see what we're given. Well, we know 3% of the population actually have the disease. So that means 97% don't have the disease. The blood test indicates the presence of a particular disease in 96% or 96% of the time when the disease is actually present. So we need to start with either they have the disease or they don't have a disease. So we're going to do a tree, and we're going to say, okay, so here's our tree, and we know that the population either has it or doesn't have it, and we know that 3% of the population actually has the disease. So that would be 0.03. So that would mean 0.97 doesn't have the disease. Now from there, okay, it's either the test either indicates it's present or not present. So you could think of it as a test positive, test negative, however you want to think about it. But we know that the blood test, and let's look at this first sentence here, the blood test indicates the presence of the disease 96% of the time when the disease is actually present. So that tells me that when the disease is actually present, which would be my top, that first branch, and then it would say, okay, 96% of the time, okay, it indicates it's present when it actually is. So the complement of that would be 0.04 or 4% of the time. And then it also says, okay, that same test indicates the presence of the disease 0.5% of the time when the disease is not present. So that would be, let's see, 0.5% as a decimal would be 0.005, and the complement of that would be 0.995, and that would mean 99.5% of the time the test would indicate that disease is not present when it actually isn't present. So here's our tree that we have set up, and I'm looking for the probability that the disease is present, or that they actually have the disease given the test says it is present. So we're going to be looking at two of these different limbs or branches, or however you want to think of it. We're going to look, the one we want is the probability that the disease, they have the disease and the test indicates that they have the disease. Okay, so let's again, given that the test says it's present, so we need to look at this branch and this branch. So we need to look at both of these branches. And if we had a third branch coming out, you would have to look at all the ones where the test shows or indicates that the disease is present. So I'm only looking at these two branches. So putting that in the Bayes theorem, so probability that the disease, that they have the disease given that the test indicates that it's present, and on top is always the one we're looking for, or what we're trying to find. So that would be 0.03 times 0.96 divided by, and you repeat that one again, and if you look at the formula, you can see where this is coming from. Plus, and now we have to look at this other one, because it'd be here or here, so we have to look at the other one also, which is the complement. If the disease, it's showing that the test would show that it's present, but it would actually not be present. Okay, so when I calculate this, or put this in my calculator, I'll do 0.03 times 0.96, get that answer, which is 0.0288, and divide it by the bottom. Okay, so if you're doing a calculator, just make sure you put it in your calculator correctly. We're going to get approximately 0.855869, and it said to round it to, I think, the nearest thousandths, so 0.856. The probability that they would actually have the disease given the test says they have it was 85.6% of the time, or the probability is 0.856.